All right. Thanks for joining us and welcome. We're going to do Getting to Know Qtx, and we're going to check it out and see what we can learn about the hardware, and then what we can talk about digging into kind of deeper into the software and the web UI, and kind of get familiarized with the platform. So going forward, as we get closer to our shipment of the new firmware and the full functionality will be ready there. So the Qtx software that I'm going to show is not available yet. It will be available shortly. I was hoping we'd have it this week, and I could tell you it's going to be ready this week. It may still happen, but keep an eye out for any emails coming from biamp.com in regards to that and being available. But we'll talk about the software, and then you can download it when available at the location I've got there in the link. It's from our normal Biamp downloads. This course that we're doing with this webinar today is not any CTS renewal credits available, but our training for QTX that I'll talk about later in the at the end of the slides, it will qualify for CTSD, CTS, and CTSI credits. So that'll be where you can go into a more deep dive and get the certification. That'll be a self-paced training. So let's get started kind of talking about what we're going to talk about tonight. So I'm going to go over the products again, kind of review the line, talk about what's different between the QTX line and previous Dynasound products and Qt Pro, and kind of what we need to look at in the QTX line to achieve the same functionality. We'll talk about how zoning is achieved in QTX, what's different versus what you may have seen in Qt Pro in the past. It's a little bit different, more flexible, and it's got a lot more options for building larger systems with different emitter types or indirect speakers. Then we'll talk about the interacting, the ways that we can work with the hardware. So from the front panel, the web UI, and then what we can do with the QTX software, where the limitations in each one of those aspects is, and where you might want to go with certain operations, which one might be the best choice for certain things that you're looking to do. And we'll shoot through a web demo. I'm going to try to do some configurations in real time, talk through the web demo. I've got some devices that are configured, some that are not configured, so we can kind of look at the differences. And then we'll try to do some things in the web UI, and then have that segue into our QTX software, and we'll talk about that and maybe pull in some changes that we did in the web UI and make those changes seen in the QTX software after we navigate through. So we'll kind of try to roundabout through everything. I'm going to try to hustle through the slides on the product so I don't run out of time with the software demo here, and we'll get started here. So just as a review of what we got in the QTX line these days is, so we've got 4 different base model controllers, each with an AVB or Dante/AVB variant. So any device that you see with a D after the part name, that's a Dante and AVB model, and a unit like a 300, just QTX 300, will just be an AVB only. So it's good to plan accordingly as you're designing systems. If AVB might not be capable of sitting on the network on an AVB capable switch, maybe a Dante model of a hardware might be a better choice, because then you've got flexibility that you can live on a Dante network or an AVB network, and you got a little bit more flexibility in planning. So our 4 models, we've got the QTX 300, 600, 800, and 805, and they kind of all do a specific jobs. 300 and 600 are expansions of each other. So the 300 kind of starts with a certain amount of outputs and square footage, and then the 600 just builds off of that, gives you additional outputs, as we'll look at in a moment. And then the 800, 805 kind of takes up where a lot of the Dynasound products filled in, with some of the devices that would live out in the plenum space and have direct connections to speakers in a 1-to-1 ratio per output. Probably what you've seen in 2021 in December, we started shipping the 300 and 600 non-Dante versions, just the base AVB versions, in a single configuration to mimic Qt Pro hardware. So as we were running into the end of life of Qt Pro and then kind of building into QTX, we wanted to make those available. So that had limited release and capabilities within the controllers. They were still at the point where the firmware was running in single mode, so you could only operate these in small configurations, standalone. You couldn't change the zoning up, so they were set up on a one-to-one. So moving forward, hopefully in the next week or two, we'll get the full functionality. Existing devices that are out in the world, they can be updated to the latest firmware, and then they can participate in a larger system, as you'll see as we start looking at the devices that I have. And you'll be able to configure larger setups that share across zones and things like that. So as we were talking about, the 300 and the 600 still support the same output types as what you've seen in the 300 and 600 Qt Pro. So we're mainly looking at direct emitters. So we're looking at direct field active and passive emitters to pair up with those devices. And then with the addition of the Qtx 800 and 805s, we have the ability that we can use direct field emitters, and then we can also mix in indirect field emitters into a design. So we're bringing in the things that we could do in Dynasound, we're pairing them up with the things that we could do in Qt Pro, and kind of bringing them into where they can be managed under one roof and one system. This is kind of the output topology. 800s and 805s, they support 4 8-ohm output amplified outputs. In addition, the 805 has mirrored line level outputs, so you could feed into a 70-volt system that's existing, or an amplifier, multi-channel amplifier, if you were doing a string of 70-volt, 100-volt speakers and supporting that, you could lead from that out of an 805. So starting with the 300, well, let's look at the back planes of all of these and look at the similarities, and then we'll go into a little bit more detail on the GPIO and balanced audio in addition to the network. So on the 300 and the 300D, the backplane, you'll probably notice that it looks very similar with the outputs to a Qt Pro. The main difference being that the outputs are labeled as outputs and not as zones. So that'll be something that you'll see along the way as we get into the way zones work. The outputs are not tied to specific zoning within the controller. Those can be defined as you need. So we've got 3 pairs of emitter runs on the 300. 2 balanced inputs for audio can be configured as line or mic level, and they are assignable within software or the web UI to do whatever function you need to do. If it needs to be a logic input for a paging microphone, or if it needs to be a background source, either one of those can be set up in that regard. All the units have the same 2 GPIO connections that can be set up as inputs or outputs. We'll talk in more detail about what those can be configured to do. We've got contact closure inputs, one being a push to talk for a microphone, and then the second always being set up as a dedicated emergency mute. So that'll be your fire alarm interface to the system, where you can mask him if there's a fire alarm and you need it for safety. Then the privacy sign outputs at the bottom there for 2 assignable privacy signs that can be set up in the zones and shown that masking is enabled. On the outputs, we've got the uncorrelated sound masking generators per output pairs in the same regard as what we did in Qt Pro. So we're running 4 channels of audio that repeats every 4th emitter and then repeats itself, so that you don't have any kind of comb filtering effect. Included with the units, the 300 and the 600 both include the power supply 24-volt DC, and both the 300 and the 600 ship with wall mount hardware. So for support with the emitter types, we're matching it up very similar to what you can do with Qt Pro. So think of the Qtx 300 as far as what emitter types and how many as being the same as what you've always planned in the past with Qt Pro. If you've used that, we can use supporting 6 Qt passive per 120 per output. So you get 36,000 square feet of coverage, and then you can do 50 Qt active emitters on the output using the emitter power injectors in the same way. So you're using that for systems that need paging or sound background source reinforcement in the space. So if you're using that in addition to masking, using the active emitters is the best bet and the way to go. So moving on to the 600, same topology as far as the I/O, the network port, and the analog. We just add in the 600 the additional 3 output pairs. So we get 6 outputs with 2 match runs. We're getting a larger square footage coverage, but the same coverage, same support for passive emitters and our active emitters with our injectors. So just an expansion with the for that unit to kind of build a large system. And quick question came up, and I wanted to just hop on it. Some of the questions I'll answer now, and then some I'll wait to the end. But good question about the Dynasound came in. Dynasound 3002, will they, and 3008, will they get discontinued? I have not heard full report of what's going to happen for sure, but in essence, the 800 and the 805 are direct replacements. So I think eventually what will happen, being that that system is a CobraNet-based system, we're kind of moving these systems along the line to being a backbone of AVB or Dante. With those older systems being CobraNet, we're kind of moving away from that. So stay tuned for that. That would probably be a good question for your sales rep, just to see what forecast of how long that would be available as you're planning out projects. So that's a good question, came up this morning as well. So thanks for asking that. So with the 300 and the 600, what we're looking at and talking about is, and I'm trying to think of this terminology as strings of loudspeakers. So when I'm thinking of QTX 300, 600s, I'm thinking of emitter runs. So I'm thinking, you know, as I'm covering a space, the passive direct or the active direct emitters, I'm using strings of those speakers to support either passive direct field for just masking, or if I've got active where I've got paging, background music spaces, I can mix and match across either one of these controllers and set it up similar to what we did in Qt Pro. The difference being where if I had multiples of this, and you'll see in some of the graphics, I can tie across controllers and have zones that share across controllers. I'm not limited to and locked into a single controller. So I don't have to manage each one of these as an island. I can bring these all in and group them as a team and a system. So the same kind of structure types for our direct masking for these support. We're looking at open structure, ceiling tile, hard lids, metal and slats, and then ceiling clouds type applications. Okay, so moving on to the 800. So as we see the back here, this is very similar, kind of building off of the platform of the DS8000. So it's meant to have PoE plus power. So it does not ship with a power supply. There is an optional 48-volt power supply. It is not plenum rated. So the recommendation is if you're putting this controller out in the plenum space to use PoE plus power, class 4, to power this device, and then it ships to you with a plenum mount kit. You can purchase the rack kit or whatever needed if you needed to put it in another space. But again, same GPIO input capabilities on this device to analog inputs, and then the same contact closure, same network capabilities. And in addition, what we have supporting is 8 powered outputs. So each one of those outputs can be set up to 8 ohm, 4 ohm, or there's a setting for a DS1320 4 ohm speaker that has the spectrum built in for that DS1320. So I'll show you in the drop down when we get into software where you would select that. It would be set up for 8 ohm, but then do the spectrum properly for the DS1320. So each one of those is individually tunable as an output, but then they can be grouped as needed within the zoning. So you could zone those all together as one zone. You could split it across those in any way that you needed to. You could split them as 8 individual zones if you wanted to, just depending on the application that you needed to control there. So as I said, matches kind of what we're looking at in the DS8000, same kind of support, but then more functionality with the amount of things that you can do with source routing to it and shared sources from other devices upstream or at a head-end location. Cool. So hop forward here. So this is kind of showing an 800 and an 805 type topology where I might have Qtx software touching my network, and then out in the field, different 800s that are mounted with mix and match as needed speakers to fit the application, and then managing my zones however I need to manage in these individually controlled loudspeaker types. So as we talked about strings of loudspeakers, when we're talking about devices like this with the multiple outputs where I'm grouping a single or a pair of loudspeakers to it, that's where we're talking about it in terms of individual controllable loudspeaker types. So I can set these up as one zone, but then I can individually on each output fine tune each output for the space via EQ to fit the needs of the space, which is very similar to what you did in the DS8000, where I could fine tune each output individually, and you'll see how we can do that in software. So our 805 has everything that the 800 has, same amplified outputs. The differences being we ship it with a rack mount kit, so it's intended to be at a rack location, not in the plenum. It doesn't support PoE plus power like the 800 does, so it's going to include a DC power supply. So the thought process in this one is to locate it at a hand-in rack. You could supply powered output to some speakers. We've got still the 8 amplified speaker outputs, but then in addition, we have 8 mirrored line level outputs. So these are balanced line level outputs that could then feed a 4-channel amplifier or something along the lines of a distributed sound system. So you could kind of mix and match as needed. We're kind of recommending that if you utilize, since they can't be broken away from the amplified outputs, that in planning, maybe to plan, if you use a pair of outputs for line level, keep those line level and then don't share across. You could in theory share it, but then you're sharing any EQ adjustments that you might do across both types. So you might have a difference in speaker type that's out there on the 70-volt system, but this would give you the option to kind of build in a full system and then support some existing pre-infrastructure devices that are in place, and then route whatever you need to it. If you need it to be masking, or if you just need it to be paging, you could support paging through just standard 70-volt C-link speakers throughout a space, and then have that piggybacking off of devices that also supported masking, so you could get mix and match as required. So in this example, we're showing 4 outputs being used to kind of drive multiple. So this gives you a lot of options for masking and just sound reinforcement in spaces as needed. So the kind of the whole point of it was we're talking about Qtx being a system that pulls in all these different types. We've got strings of loudspeakers, we've got individually controlled loudspeakers, in a mix and match of any one of those that we can put into one system and it create a scalable solution. So let's talk about the topology outputs, inputs on the back side of each one of the controllers. So we've got, for analog, as we said, they're configurable as paging and music sources. So you define what you need it to be, and then in the software we'll show how that is programmed to be masking or a paging or music. So the most important thing to think about in this is that they are not mixed together when they're set up as a music background input. They are selectable. So they're kind of like a source selector in Tessera, where you've got multiples and you're picking one of the two. When you set it up as a paging source, then you create logic that can then trigger a ducking on a background music source as a page comes in. So that's an important thing that's been asked a lot of times coming into this with support. We get a lot of questions about can we mix left and right audio or something and use those simultaneously? And they are currently in their state set up to be discrete, and you have to select between. They can be used for micro line level. There's phantom power available on all inputs. And then we've got preamp settings that'll get you from line level up to microphones that have a really low sensitivity that need a lot of gain. And again, analog sources may be shared across the system. So if you've got a larger system and like you have Qtx 300 at a front end location that has my paging microphone and a page is set up to go there, I can spread it to multiple floors over AVB and Dante as needed, as I've programmed in the software or the web UI. On our interface connections for Logic, we've got our GPIO. So we can configure the GPIO 1 and 2 as push to talk or mute zones. And then I can also configure as an output, so I can get a talk now indicator. So if I had a system that was requiring contact voltage 5 volt or something to get a trigger, I could set that up in that regard. And then that's a view from the software, kind of where you would set it up and define what zones you wanted mutes or push to talks to occur in. Our contact closures are next one in the middle there. We've got the position one as the dedicated emergency mute. It's muting everything, all outputs in the system. So if there's 5 devices in the system and it gets a contact closure on device 1 in IDF1, all devices will go into a mute state and show in the system that there is an emergency mute active. So you'll get an indication on the front panel. All masking and sound will be killed to the system until that returns back, and that is manually set to be active low, and it's not changeable. So it's going to sense a contact closure to trigger that. Position 2 is configurable to be a push to talk. And the difference between that push to talk capability and the one in the GPIO is that it's configurable only as an active low. So if you get a microphone that needs to be set to active high, the use case would be to use the GPIO connection so that you could select the active high setting and allow it to do kind of an inverse of what the contact closure 2 does. So good to note. You could support multiple contact closures if you needed to. If you had a mic pat type paging microphone and you wanted to utilize the same microphone and have 2 different pagings, you could do that. Have button 1 page to certain zones and button 2 page to another zones. You could set that up. And then we have our privacy connections. We can do 2 signs assigned to a single zone. So that's showing where we would do that in our software. Moving on to the network side of things. So all the Qtx network controller, they share the same network kind of topology and support of ABB and Dante as needed. So pick your device, your style. So if you're getting the ABB only version, you'd want to be planning any transport across the network to be used on an Avenue certified switch. So you'd want an active license. What you'd run into if you did plug in an ABB system and try to share a resource, whether it be a microphone across a non-AVB capable switch, you would get masking because the masking is supported and is running off each controller, but you wouldn't get a shared resource. So a microphone coming in at IDF1 might not make its way to IDF4 and you'd get an AVB fault. So again, going back to what I was mentioning about planning ahead for the topology as needed for ABB or Dante. If you had a Dante system, that doesn't require the specific ABB license to run on the Dante switch. There might be other things that you need to set up for the multicast to be supported, but it might not be as finicky as far as getting a specific switch for a device. So all of the devices by default are set to DHCP. They're capable of static addressing, and they also default to link local. So you could set those up to pull up in single cable mode is default. So what you would have on a new fresh out of the box or a factory reset would be a device that would have 2 IP addresses on single cable mode and in dual cable mode. So what you've got on the back panel is ports 1 and 2. When you're in single cable mode, which is the default factory reset and out of the box behavior, is port 1 control and media is supported on everything's there. So your device discovery and any inter-device audio being shared. So whether or not that's an analog source coming in that's sharing from one controller to the next, or if it's a digital media source that's coming in from, say, a Tessera's bringing in a feed in via background music, that would be coming in port 1. And port 2 in this mode is completely disabled. If you plugged in something to it, it would not light up and show any activity. So it's just completely off and not discoverable. No Wireshark activity would be seen on that port or anything. In dual cable mode, you can separate them out, and control jumps over to port 2 when you're in dual cable mode. So you would then do anything with discovery, sending configuration files, finding devices on port 2, and then port 1 would this only be used for our media transport. So as I'm looking at in this view, the way that the network ports would look in a single cable mode, as we can see that there is 2 MAC addresses and 2 IP addresses that are seen behind port 1 in single cable mode. It's the same 2 IP addresses and MAC addresses that are seen in dual cable mode, but it is important to note that if you did have a system that was connecting to a switch that might be disturbed by seeing 2 MAC addresses coming from one device, that would be something that is taken into account, because in single cable mode, both MAC addresses are seen. If you Wireshark traced it, you'd see advertisement off of both. So they are both available and uniquely assigned. That is not available to be turned off necessarily. Couldn't turn off media if you're in single cable mode. So they're sharing the same backbone, and that is the default network configuration. So this would be kind of what you'd see on, and in this case, this would be like a Dante version. We'd see it in single cable mode and the media type set to Dante. Link local enabled, DHCP enabled, and it'd grab a link local address. So in a configuration of dual cable mode, we'd separate it out, and LAN 1 would handle all our inter-device audio that needed to be shared, and then our control network could hit the enterprise network and be shielded from any of that media traffic and offline from that. So if you had a situation where you wanted to put an AVB switch, say a PC5 or something on a smaller system to just manage your AVB between devices, you could use dual cable mode, set up your TC5, plug it all in, let that be link local to transport between devices, and then do a fixed IP address on your LAN 2 connections, and then land it on the larger network for management. So all devices within the system, it's important to note that they have to use the same network audio transport. So everything that participates in the system needs to be AVB if it's in an AVB mode, and all Dante, we can't mix and match operations. So we do need to plan ahead of time to set those. The setting between AVB and Dante it requires a configuration clear to change that setting. So single cable, dual cable mode can be changed in runtime if needed. It doesn't require a configuration clear. So you can do that as needed on the fly. If you needed to change a device, so like an out-of-the-box device that was a D variant, if we needed to change that to live on an AVB network, probably our first step would be to discover the device, clear the configuration, and change that media type to AVB, so that then you could bring it into an AVB backbone if you were going to go that route. So 2 ways that media is shared across the network. So we've kind of got the idea of an analog input being brought into a controller, and then being converted over to an AVB or Dante flow or stream, and then distributed to appropriate areas of a device configuration. So we're using the media between devices to bring analog in and then take it to where it needs to go as defined within the zone routing. When we do it this way, we don't have to do anything in AVB Manager or in Dante Controller to make this all happen. This routing is all being done in the configuration. So the Qtx software, as it doesn't really compile, but I kind of think of it as it's compiling like into Sarah, where it's telling the devices how to set up the routes between the devices. So under the surface, it's setting up implicit device to device control and traffic between there to get the signal to the appropriate zones. And again, the masking is generated at the controller level. So that is not, it's not generated at device A and then over the network. We're only bringing in external sources and then bringing it to appropriate zones. And then the second way that we can apply AVB and Dante in our system is by bringing explicit streams or flows in from an outside device and defining them in our software. So in our software, we'll look at, you can set up an analog source, you can set up a digital source. And this would be where if we were bringing it in from an external Dante or aux source or a Tessera server, we might set up a background music feed that overflows into the masking. And depending on how it's set up, those can also be done and set up by appropriately naming the host name and the channel name. that it will set up the routes for us on Dante. An AVB still, upon release, you will need to get AVB controller and route those manually. So that'll eventually be a automated process where that's built within the file. But upon the release that we have that's going to be on the streets soon, Dante will automatically route if you get everything right with the host name. You enter in the host name, enter in all the device info, the routes will be made for you. AVB still make, so if I had a Tessera that I needed to route, I would need to go in there and select the cross points that I've defined in AVB controller, if a RIDL or another controller of your sort, of your preference there. So this is our overall model comparison. This is on Cornerstone. It's a good reference to go and look at kind of per device setup and what's available. So quick word about the way that virtualized zoning works in QTX. So in Qt Pro, as you may have seen in the past, that the zones are defined, the outputs tied to the zones, and they're named that way on the back. QTX would be in outputs. We can create any groups of outputs to become our zone. And when they're assigned in a zone, they work in unison. So what happens is, as I'm building a system, if I want a group of emitters, passive or active, to get the same source and have the same overall level where I've got a master control level, I've got that ability by grouping in zones. Now, I'll still have the ability downstream that I can change the output level or fine tune as needed per output basis, but then almost like it's my master volume for the zone is upstream from that. And I'll show you that in an image here in a moment. So kind of the overall feel of a system architecture is you define what speaker emitter types if you've got direct field or indirect field per output, how you want to match them up, choose your controllers, match them to the outputs, and then define your zones based on what's in the needs in the architectural space. So how you would group your inputs to that, how you want to control them. Then you've got your sources, wherever they need to go. You've got your assignment, and then that kind of pulls all together as a QTX system. So this is kind of the way that the outputs would show. So my multiple outputs can be assigned in a zone and then grouped together to function as a team. So this would be the way I would look virtual zones in the QTX software. So as I'm defining a zone, I've got a full system zone setting that's got my master volume, my selection of background audio, whether or not I want masking to be on or off in that zone. And then I've got an overall master level for masking versus background music versus a paging source. And then on a per output basis, I have the ability to bring up every output and fine tune a level per output. So I've got, if I have a specific space that needs more of the paging microphone, a couple of outputs need that, but the overall level is okay to the full zone, I might go into the output and make fine tune adjustments as needed. This would be also where if you were bringing in an emitter type or speaker that needed fine adjustments per output for custom tuning, you could go in here and the equalization on a per output basis. So just looking at quickly through some of the zoning scenarios and the way it would look in QTX software. As we get to the software, we'll look at that closer. This is our individual controlled loudspeaker types showing the way it would look with zoning. And if I wanted to change my mind and group all of these open cloud ceilings on all these floors together, I could then change that zone up, create a completely new zone that's everything tied together as one group if needed. We can mix and match all the direct and indirect field emitter types in one system, so we're not limited by putting like a Dynasound system in one space and then QTX or Qt Pro in a smaller scenario in a first floor area or something like that. So hopping over to the user interfaces, we've got the three ways that we would interact. So the simplest way, very basic control, would be our front panel control. So we've got system-wide level controls, network functionality, some settings that can be changed, some settings that can be viewed, only in viewed, seeing faults in the system. The next level would be kind of getting into the web UI. That gives you more advanced functionality, but there are some things in the configuration side that are not achieved in the same way as the Qtx software. So if you want full control, need to see devices configuration offline without having hardware in front of you, the best route would be if you're planning ahead of design, the Qtx software is that application. So you can build these configurations without assigning to devices and then assign devices as you get on site with systems. Where I kind of look at the web UI as somewhere where I'd go and plug into a system to make a change on the fly or make a quick adjustment. That would be where the web UI might be best suited. All the devices come out of the box with the default configuration. As I mentioned about the network capabilities in default, same kind of thing applies to the zones. So all devices somewhat mirror what Qt Pro does now and what the QTX does now, where it's on a one-to-one basis. So if I factory reset a QTX 300, I get a one-to-one. I get 3 zones and 3 outputs assigned to the zones. I get 1 source input that's by default defined. So I could plug in something right away and it is already routed to all zones as a music source. So out of the box, you could get a masking system, plug it in, turn it on, and you'd have audio coming out to your the outputs. The one thing that you won't have is if you did need to assign passive versus active emitters. So that still needs interface through the web UI. It's not been ever supported from the front panel. It's a feature request that we'd like to have from the front panel, and we've had a lot of requests to have that. Still in QTX as it stands with the way that you'll see it in the next few weeks, it will still require that. So if you get it out of the box and you have active emitters, you'll need to go in via the web UI and change that. So front panel device, I'll break it up into 3 sections. We've got 2 pages that are seen that are device info. So as I scroll through my front panel, what I generally will see as a first is my my version number. So I'd see my firmware version and faults in the status. Scrolling to the right, I'd get my host name on my device, which I could use to get to the web UI. In addition to the network IP address, you can use the host name. This default. The default host name is always the model name with the dash and then the serial number. So that's also a way from quick view that you can see serial number if you do need to get any service done on it or anything like that, and you need to retrieve that quickly. So, and then scrolling to the right from those 2 device info settings, then we get into the network settings. So we have the control network and the media network settings that by default are DHCP with link local, and then can be changed to, from the front panel, change to static as needed, turn off DHCP, assign a new IP address. That can all be done from the front panel committed to the devices. And then scrolling past all the network interface, then you get into the zone control. So by default, the zones you would see on the 300, you'd see 3 zones. Each zone would have 3 level adjustments. So you get a masking adjustment, a music level adjustment, and a paging adjustment. And then there's a zone mute. If you configure it differently in software, you clear the configuration, do something new, the new changes and the naming convention that you use in the software or in the web UI gets translated over to the front panel. So if I name it specifically to the space that I'm working in, I will see those changes. You don't have to use the generic zone 1, zone 2, zone 3. So you can get more flexible in the way that it needs to be viewed. So moving on to the web UI. By connecting to one of the devices on a network in the same subnet, we can see other devices that are out there. So it's kind of nice if you're on the same subnet and you don't know a device on the other side of the building, as long as it's in the same subnet, we can pull it in and look at it. We can at least see what its IP address is by finding one device. So and then we can we do need to connect to it individually to do some of the functions, but there are some functions that we can do from a device by adding it to a system in an unconfigured state. So we'll look at that in a moment here. So again, QTX 300 and then the host name there, go get you to the web UI or the IP address. You can get to the web UI from either the media or the control IP address on the front panel. So if you're in single cable mode, you can hit either one of those IP address to get to the web UI. Dual cable mode, same thing, just plan on the one that you've got the proper port plugged into. So if you're in the control network on a dual cable mode, use that IP address to get to the web UI if it's separated. So the things that are supported in the web UI, I'm going to just let you look at the list there. We're mainly able to discover the devices and assign them. We can do basic configuration. It's more in a listing view that you see it in the web UI. You can do it. I find that if you get 4 or 5 devices, it's manageable because you have to go between pages to assign zones. When you get to a larger system, the software is a little bit easier to view everything. We can get in and do all our logic programming offline, configure our audio sources, add audio sources. We can get into all of that. We can do live settings for inputs, outputs, and zones, and then anything scheduling, view faults, make changes. We can update the firmware to the device that we're connected to. So that's important to note that we can only do that to the device that we're connected to. We can't do a bulk firmware. We can set our security and access levels. So I can set up different users to have different access to the system from the web UI. What I can't do from the web UI is bulk firmware updates, as I mentioned. So I can't send out to all the devices in the system a firmware update from one UI. I could send a configuration to a group of devices, but I couldn't firmware update. So I'd have to do that on a case-by-case basis. Now, down the road, we will be able to manage that better by using SageView. So SageView will be able to, in the future, support and view all devices on the system, and then you could bulk from SageView, but you can also run a bulk firmware update from the Qtx software. You cannot use any floor plan imaging. You'll see in Qtx software that you can import a floor plan and draw over it. That's not supported in the web UI. And you cannot load a previously built system file that's done in Qt software in via the web UI. So you have to load that. So if you build a configuration offline in Qt software, you send it over to the person that's working on site. They would need to use the Qt software to load that system file. We couldn't import that right now and load it that way. Managing any kind of certificates or 802.1x is not supported with the web UI. That has to be done through the software. And NPX paging integration is going to be a feature release coming shortly. It won't be on this next in the next few weeks, but it's going to be it's on the roadmap and it's coming down the line as the next firmware release to support that. But when that does get involved, you would need to use the Qtx software to program your network paging stations, and they I'll show how they import as a device. They're going to show up as a device. So I'm going to skip over these slides. These are going to be in the PowerPoint that you can view in real time later and just kind of look over the different sections of the web UI. I'm going to switch over to live view of my system so that we can look at it in real time rather than just talking through it. So what I've got right now is I have 4 controllers, 2 of which are running the factory default configuration. So I've got a Qtx 300 running factory default and an 805 running factory default. And then I have 2 devices that are unconfigured. So I've cleared the configuration after I did a factory reset. I've got them sitting out there. And if I were to look at those devices, they're available in the network, but they have no zones assigned. So they're essentially waiting to be added to a system or have a configuration loaded. So what I'm going to do is I'm going to look at show you through the configuration windows, what's available on the system, and then look at the system view. So we're looking at live settings, and then we're going to add in a device that's cleared into a system and then show some of the zoning, and then that will transition us into the Qtx software, where we can then view what we did in the web UI and then take it to the next and view it in the Qtx software. So let me switch over here and show you my devices, and then we'll talk through what we have here and try to get you what you need. Okay, so as you can see, I've got my 4 controllers web interfaces open on my screen here. This is my configured so it's set to factory configuration. So if I look at the system settings, I can see that this Qtx 300 is running a factory configuration, where this one is not running a configuration. So this device is cleared. As you probably can see, that there's one extra set of pages that's not available to me. I've only got the ability to configure a system. I don't have the ability to do any system settings within the unconfigured setup. So this unconfigured device is ready to have something done to it. I'm going to leave it unconfigured because I'm actually going to bring it over and add it to this system that's already running on this. So before I get into that, I'm going to look at the what you'd see in the zone settings and walking across here from a factory configuration. So as we go from left to right, we've got our zone data. So as I showed you in the output view there, it shows that I'm on a one-to-one output. So on each output, I've got a zone assigned. So, and by default, one background audio is created and it's assigned to all of these zones. So this is my master level control for each one of these zones as I scroll through these guys. If I define this as a one zone system, I'd only have one selection here. So this would be where I would go and make adjustments. This is also in tandem to what is seen on the front panel. So if I were to, let me go back to zone one. If I were to hit the zone mute on the front panel, I see it reflected here. So these work interactively with the front panel. So me changing something on the front panel, it's reacting to these zone level controls. So that is a good way to see, like if I make a change one place, it is interactive with the others. So you've got each one, any created source background inputs are available. You can create 2 per controller, but they can be shared across multiple controllers as we told. We've got always set the automatically update. Real-time changes are made to it as you adjust these. So we're making these live changes on the fly and don't have to save these to the device. So the way I look at it is some of these device changes, if they're locked into the device, if they're already programmed, we can make them on the fly. If we're making a fundamental change to the topology, if we're changing a logic or an input, a quantity of inputs, naming an input, something like that, that would be more of a configuration change. So that would require us to go to the configure system to send an actual update to the hardware. And when we go to our device list from here, we see that this is the only device participating in the system. If we had a multi-device system, we'd see all the devices in the device list that participated in the system, even if we were connected to just this one device's web UI. We can see any faults. My system's not in a fault state. I could trigger a fault, but for the sake of time, I'm not going to do it. But I was triggering an emergency mute fault earlier to show that, but I won't go that route. So in this output data, this is where we would go to do our per output adjustments. So I can go to each output and I could fine tune. So if I had a master level control, and say I configured all of these as one zone for all 3 outputs, and I wanted to set a master level of everything, but then I needed to make a fine tune adjustment on one of my runs, runs needed paging a little bit louder, maybe for some reason. Maybe it was a reverberant space that was a cafeteria area or something. I needed to just bump that up in the zone, but it was perfect in the other zones. This would be where I could go in and do a fine-tune adjustment, give a couple of dB adjustment per output, and I could take output 1 and adjust that as needed, and then save the changes to the system in real time. And then I'd update that. Also get a peak meter of, it's a summation of all of these. So it is not seeing just one of the inputs. So if I were to bring masking down, my meter would actually, let me bring it down in the right zone here. That save changes, my meter would drop down. So that's, I've got a microphone and that's what you're hearing now. So be nice to have 3 different meters, but I'll take just one. But what I've usually done on troubleshooting is if I needed to verify my paging to a zone, I'll lower the masking so it doesn't inadvertently show me something that I don't want to see there. So that's our outputs. And then we've got our input data. So this is where we've programmed, already set up our inputs per controller and set up the preamp gain. So this would be where we'd go and change in real time. I could set up in a configuration and go ahead and set preamp gain to match the mic, or I could do this after the fact, after it's already been deployed, and make this change in the system in real time. So in this particular unit, I have a small microphone here that I'm tapping on and I'm just using as an input to the system. And then we've got the ability to view both the inputs on the device. If I had multiple devices in the system and I tried to view an input for a device that I wasn't directly connected to the web UI, you would be able to make the changes, but the peak meter would give you a warning that you can't see the peak meter unless you're connected to that particular device's web UI. So that's a little bit of just something to keep in mind if you had multiple devices and you needed to set up preamp gain or something like that. We've got the soft start. So if you had a device that was going into a space that was already occupied and you needed to ramp up over the course of a week or something like that, we can do that in real time in the system settings. We got the ability to do scheduling. So I could create a schedule for certain days of the week to turn on and off zones, mute audio, maybe lower a zone or raise a zone as needed. And I can set up a schedule as needed and commit to the unit. That is also a real-time update that I can make. And then within the system settings, I can also set the date and time, which would be important when we're doing schedules for logging and things like that. By default, it's going to have NTP enabled to look for the NTP server that's listed there. We've got the ability to view the device info. So we can also add info about the device for future reference and things like that that'll be available. This would also be where if I had a configuration that I wanted to clear out, this would be where I could clear. Right now, the download configuration pulls a JSON file that it's viewable by if you had an error in the system and we needed engineering to look at it, but we can't really take that JSON file and open it in Qtx software or import it from one unit to the other. So right now, I've kind of been instructing that that's more for use of diagnostics and configuration, cross-checking with if there's an error in the system or something like that, we'll pull that down to go with engineering logs. And then we've got the ability to protect the system setup administrator levels control. So jumping over to configure system. So we've got a configured system, but if I wanted to make a fundamental change in this system, I would go in here and work within the configure system setup. So I've got all my the devices that are on this network and the shared network available to me. I see certain ones that have the checkbox. If you notice, the ones with checkboxes, they are the ones that are unconfigured. So if a device is configured as part of an already running configuration, I can't add it to the system, but in the event that one device is unconfigured, I could piggyback that onto the system and add this to this current configuration. I can also go in here and change up the zoning. So I'll show you this in a moment. I'm going to come back to this, but if I wanted outputs 1 and 2, I'll go ahead and do this. I'm going to go and group these two into one zone. So I'm going to change this by selecting, and I'm going to move the selection to zone 1. So now outputs 1 and 2 are now going to act as zone 1. What I'm going to do is I'm going to add this other device. I'll go ahead and do this. So my other QTX 300, I'm going to go ahead and just build this into the system since we're doing offline configuration changes, so it's a good time to do that. So I'm going to go ahead and select that device that's unconfigured, and I'm going to move that to my system, which is actually the floor 1 system here. So when I hit move, now this device is going to show up in my available zoning. And since it was unconfigured, it needs to have some things done to it. So say in this situation, I might want to have zone 3 that's there on the output and output 3 of this new controller. I want them on zone 3. So I select and then hit move. Now I've decided to go, so I've got a zone 1, zone 2. Now I'm going to make these two group together into my pre-configured zone 2. So I'm gonna kind of span across 2 controllers with this setup. Moving to the right here, this would be where I would set up all of my logic I/O. I'm not going to go into any additional logic here, but this would be where I could do a push to talk, assign the functions to the zone, and what source I wanted to be assigned to that. I'll leave that out for right now. This would be also where I could go in and do assignment of push to mute functions, or output mute functions. So these are all configuration changes that I'd be doing offline. So by default, we've got an analog source. I'm going to go into it and leave it the same. But if you needed to add a source, we could go in here, add a source to the system. We have our zone listing showing our status. this would be where we want to go and assign background sources and turn on background audio while we're in an offline state. So if I created a new background source, this would be where I would see it show up as an additional background source. No changes were done there. This is an important one here. This would be where probably a common question that gets asked about changing the emitter type. So if I had a setup, and then by default, you see both of my controllers are defaulting to passive. So in this case, my zone 1 is going to stay passive, but I want zone 3 to be active. So I need to set each run associated with that. And I'm going to go ahead and do zone 2 as active. So maybe I've got a zone 1 that's serving just offices that need masking, and then I've got some areas that need paging in addition to background music or something like that. So once I've made those changes, I want to send that update to the system. And I'm going to call this new system, give it a new name, consisting of 2 devices. So I'm going to go ahead and send this over. While I'm doing that, I'm going to hop over to one of these other configure devices just to show you the device settings while that's configuring, and then we'll hop over to the software. I'm getting close on time here. I want to give the software a little time. So we've got our device info. This is where we could give it a name. We could pull event logs and engineering logs, and we can log the front panel. And this is also where we can get into the network settings of the device. So as we see this device, I can change the cable mode if I needed to, but I can't change the media type. But in this unconfigured setup system, I have the ability to change the media type. We'll wait till we get to it there. So in this unconfigured 805, I now have the ability to, if I wanted to add that to that previously working 300 that was an AVB mode, I could set this 805 to be an AVB mode and then run that. And then we've got the ability to choose and update firmware from the web UI to the device. So we choose the file and then go. All right. So now in my system, I've got 2 devices running. And then if I go into my zone data, I see my new zoning. And now I've got them grouped together across multiple controllers. All right, so let me hop back over to my slide deck real quick, and we will transition over to the software, and I'm going to try not to take too much extra of your time, but so the Qtx software, it's going to be available soon. I was hoping that you'd have it where you could download it right after this and check it out, but it's coming soon. Just keep an eye out for the email that says it's ready, because I know everybody's ready to take a look at it and get used to it. So what we got on the Qtx software, we can import floor plans. We can do the zone layout in a more logical, viewable way. We can set up the controllers. We've got additional full updates to full devices for firmware, and then a lot of the same level adjustments in real time and configuration changes that we can do in the web UI. So I like to look at the software in different regions. So this is kind of the default. Once you load up the software, the view that you get a kind of a floor plan view, a configuration view with properties, and then you've got at the bottom your devices and systems. So going across the top, we've got our controllers and our zones as we want to define them. And then we've got our configuration, which mirrors a lot of the same functionality as the configuration tabs that we looked at in the web UI. So a lot of the same functions are built there. And that's in this section. So configuration, and then the ability to load the configuration, send the file is in this network tree here. That'd be where you'd send the configuration over to the system. And then if there was any errors in the configuration, you'd see it in the bottom in the configuration output window. So it would give you some validation results, kind of like the compiler into Sarah, you get if you had an error in the system. And then we've got the devices and systems tab. And this would be where you could see in real time what's going on. So that it correlates a lot to the systems tab within the software, with the addition of the things that you can do with network settings and things like that are all in this devices and system tab. So this would be where we go to do firmware updates, event logs, configuration clear and get from systems, and then viewing and setting things in real time. All right, so let me launch up the software here and go over the regions here. So again, this is the view like we looked at. All my discovered devices are kind of showing up here in the Devices and Systems tab. I'm gonna start at the top here, just normal type of file structure. So can import and create new and build as needed. We've got some options on the look and feel. You can set it to a dark mode, change the toolbar buttons. I kind of like them to large. The small is a little bit small, but in some cases, if you need more real estate, you can set them to small. So that's in our options. And then we have the ability to add floor plans or floors. So, and by default, you're going to have a single floor that can be named. So you could say, whatever you want to call it, and change that floor, add a new floor if you need to. It's just a kind of a way to see and visualize things. You've got your zones, which correlates to the zone tab here. So this would be where we want to select and define what regions we want our emitters to all kind of group together in. We've got our emitters. These don't represent strings of emitters necessarily, but kind of the group of emitters. One emitter will represent that output. And you'll see as we drag it in, and I'm going to pull the configuration I just loaded to the web UI to view that. And then we've got our controllers. So grabbing the controller that's appropriate with your hardware list. So if you get a bill of materials, you could pick your controller. It's important to make note of the device type as you're dropping it in, because when you're assigning it to a physical device, if it's not matched up, even if it's running in AVB mode, a 6D, if it's non-selected right, it won't show up as an available device if it's cleared. And it needs to match up with the actual hardware type. So that matches also with the devices here and the emitter speaker. So there's redundant system items that are across the top that graphically show here. So I usually just go here. In the view, this would be where you could go in and turn off windows as needed to kind of free up some real estate. Say you had a larger floor plan, you might want to turn off the configuration while you're dropping in devices. When you're done with properties window, you can kind of toggle that on and off, and obviously devices window. So we've kind of got the 4 floating windows that can be moved around, turned on and off as needed. So sometimes when I've got a larger floor plan, I might pull the floor plan and pull something, drag it to another screen, redock it as needed to get the most out of the floor plan if I'm working with a bigger system. All right, so since we went through that, I'm going to go ahead and pull the configuration we loaded. So as you can see in the devices and systems, we've got the devices tab, which is showing everything that's out there in the network participating in a system, but we've also got the systems. So that's a group of device or single devices that are running configuration. So in this case, I'm going to just turn off this configuration output so we can see the systems. So the system we just updated via the web UI consisted of 2 devices. That's it here. So if we wanted to pull in that configuration, we'd select it from our systems window. So there's certain things that you can do from the devices window. So you're mainly doing things related to reboots on a per device, grabbing event logs from a device, changing network settings on a per device basis. The selections across here will turn on as applicable. So in this case, if I've got a device that items can be changed on, it'll allow me to change them. Within a system setting, if I select this system, I have the ability to pull event logs. I can also grab the configuration off of it, or I could clear configuration. In addition, I have the live setting. So this is our zone control. I'll show you on this inputs why it's grayed out currently in a second here. But let's go ahead and pull this configuration. So this is going to be what we ran in our web UI. So this is our default configuration that's then been modified. So it kind of pulls it in, and we're hoping to get this cleaned up so that when it pulls in from devices, it does it in a little bit prettier fashion, but it kind of arbitrarily puts things in places. So I like to usually clean it up by moving things so I can at least view it a little bit here. So this is what we did in the web UI. So we assigned outputs 1 and 2 to a zone from controller 1. We shared output 3 from this controller to output 3 on the other controller. So we got a zone there, and then we've got this zone 2. So now that we've got this pulled in, we could then make this a little bit more self-explanatory. We could call it by floor name, color code as needed. But at this point, we have a configuration that then we can make updates to. So if we were creating from scratch, we would kind of go about it in this way. We'd pull in a controller, maybe pull in one controller, I'll scoot this over to see it, and I might define my zones as needed. So the zone might consist of all outputs in one set. Maybe I've got all 3 of these guys running as one zone. Want to have them run in tandem with sets of emitters. I might set it up in that way. And then when I send that over to it, that zone will be created to support all. And then you've got just one set of outputs on the front panel that you can control. I can also, maybe in this application, I'll move around some of the things that we did here, and we'll group, we'll delete some of these guys, and we'll put in, I'm gonna run these guys as one zone. Maybe create this zone like that. All right, so now that I've got that defined, as you can see, I've already got my physical devices assigned. If I were doing this without assigning it yet, I might go in here and I'm going to just show you what my 805 that's unconfigured would look like. As I drop in a device, it's grayed out. It's not giving me any, this would be our offline mode. Like if I was creating this ahead of time, I'd want to assign to a physical device once I had it on the network. So I could create a full file, save that, and then once I got connected to the system, then I could physically assign to a device. Once assigned to an available device, I get that more turquoise type image there. So this is showing that I've got one 805 available. If one of my 805 is running a configuration, so I wasn't able to add it, but my other one is cleared, so I could, in theory, add this to this configuration. So just for simplicity's sake, I'm going to create a single zone with one speaker. We'll just keep it simple. So I'll do another zone there. I'm not going to even name it. We'll just add this 805 to this configuration. So I've got some offline changes that I could set up as needed. So I could go ahead and enable audio on the zones. Some of these were done with my previous configuration. This is my zone that I just added. So I might want to do something new where I select background audio to be active and then select my audio sources. And my devices tab is where I would go in and do any of my definitions of logic and emitter change. So this is an important place down here. Make that a little bit bigger. So my device, if I needed to change this 805 to be all 1320 emitters, this would be where I'd go and do it. I could do it on a per device basis or per output basis like this. If I had a much larger system, I might use the bulk update to do the same thing to multiple 800s. But in this case, I'm going to go ahead and set that. If I was assigning a new source, I might go over here. So what I'll do is I'm going to jump back to this. I'm going to create a background music source or a paging source. I've got a background. I'm going to call this my background music. So I'm going to rename this BGM. So this is utilizing analog input port 1 of the QTX 300 number 1. So as you build these, you can get granular and change these naming from the default to make them make more sense in the design. So I'm just leaving them as default, but I could go in here in the properties window and change the name to make it more relevant to the design. So before I can do anything with the logic, I need to create a new source. So I'm going to go ahead and just create a new paging source and make it an analog. This would be where I could also make it an AVB or a Dante, depending on how I had it set up. And I'm going to assign it to my other QTX 300 utilizing port 2. So once I have that source defined, I can make either one of these a paging source. So I've got those selected in the same way as I can make these available to background music. So anything that's created can be a background music source, or it can be a paging type source. When I define it here as a push-to-talk source and I assign it to the proper zones, then what will happen when I send the configuration and the push-to-talk is triggering the logic, then my paging input will duck the music input. So if I've got background music running, it'll duck that and then let my paging go through. The masking does not get ducked, and it doesn't currently allow for muting of the masking when a paging source. That's been a feature request right now in its current state, and when it's released shortly, it will not have that capability. So look for that in the future. I know that's been a feature request, and that is something that Qt Pro can do. And so that is good to note that is something that's coming down the line here. All right, so now that we've kind of set up all these sources, we've changed the emitter types on a per device basis. We've assigned our logic as needed. We could do bulk updates. So if I needed to set up anything to a large amount of devices, this would be where I could do that. I could set up multiple emitter types, change across devices, and just send one large update rather than to go and change that in the software on a per output basis. All right, and then we've also got the soft start available here. So that's as we're transitioning a new system on an active scenario. So once we've got these updates made and we've assigned to physical devices, I might give this a new system kind of an edit update name. So we've made some changes. We've got the assigned devices. Our preamp gain, we could go in and do this to our second QTX 300. We could do this while we're offline and commit that change, or we could do this after we've sent the configuration from our live settings to make that change. And maybe if in this paging mic, I might want to make the adjustment after the fact. So I'm going to go ahead and send the configuration. I'm going to just save it. It's going to always prompt me for a save. I'm just going to call this the test one and save it and replace that guy. And let's see if there's any, there was no errors in my configuration. If there had been any errors that were triggering, my configuration output would have triggered and told me what they were and give me an idea of what to go to look for. My most common one that I'm running into as I build quick systems is I always forget to, as building a new system, I will sometimes forget this description field and not enter a name, and it'll prompt you to enter a name. So once this gets configured, it'll give me a completion, and then I'll be able to look at my real-time settings. Now we're running over on time. I want to just make sure that we all right, so I got my system now configured and I'm running. So now if I go into my system, now my system has got 3 devices available to it. So I'm going to pull this in and view my live settings here. So I've got my zone settings where I can change if needed if I had multiple background. Again, this is my per output zoning. This is matching with my front panel. So now on my devices, my front panel has this additional naming convention and additional zone. And then I've got my per outputs, so I can go by controller and do fine tuning as needed per zone if required. The passive emitters or active emitters are going to run their proper spectrum. My 1320 in this case is going to run its proper spectrum due to my selection. Now, if I've got multiple controllers that are utilizing analog inputs, my analog input availability will only be seen when I select the controller that analog input's associated with. So in this case, I have a 300 that's at my desk. If I select it, I can see its analog input gains. I can make changes if needed in real time. If I needed to see this new source that I created on the other QTX 300, I would need to select it on its own and then make changes. So now if I had that input and I needed to make my adjustment for my paging mic, I could do that in real time and apply those changes. And if I selected everything, as you see, it's got multiple spots so my inputs aren't adjustable. So on a system, I've also got the ability to set the security on an active system. And then I can also set up our schedules from this location on an active system. So that's the software in a nutshell. I'm gonna hop back over to the slide deck, try to wrap this up here. All right, so as we're looking forward to the forthcoming QTX capabilities, so at first customer release here in the next weeks where we're doing this full functionality, we're going to be limited to 55 devices in a system and 440 zones. We'll eventually support larger systems as we grow. We've already started testing larger systems, but we want to make sure the stability is very good across these devices and the shared resources across. The API and SageView support is coming. So as we go into it, the SageView will be the control and management application, and then the API for external control will be using a RESTful API. So it will be available to do it that way rather than right now. Telnet control will not be available. It might come in the future, but the plan is for the RESTful API to be the point of control from external device to the system. Impedance monitoring is coming down the road, and NPX integration. So for right now, NPX is not going to be supported. Once it gets released here, we would need to, if you needed to use NPX, you could use NPX in correlation with the Tessera controller and then output ABB over to a system if you needed to do that in the meantime. And then 802.1x support is going to be fairly limited. It's not supported in the Dante, in single cable mode won't be supported. So only would really be supported in dual cable mode on the control port. So we got some resources available on Cornerstone. There'll be more forthcoming, probably 10 to 12 more articles coming that are step-by-step things. Some of the things we talked about tonight and in the layout of the web UI, and then some of the software kind of step-by-step programming. We've also got a self-paced training that's coming soon, probably 30 to 45 days out, that will be available on biamp.com that you can register for. And it will have CTS credits, and then it'll also walk through pretty much everything we talked about in a fashion where you can do a step-by-step. So we're going to have a dissected kind of example project, configuration from the front panel, configuration through the web UI, some basics on the software, and then there'll be a design that we'll walk through, and it'll walk you through the first floor, and then you'll get to do the second floor on your own and kind of build a system, a two-story system, and then apply the skills there, go through the network, and then have a final assessment and practice on it. So that's coming down the line very soon. And then always we've got our design team that can assist with any quoting and design questions and layouts. And I know they're already working on QTX designs, so feel free to reach out to them for designs as needed. I think that is all I have, and I ran over a little bit. I apologize, but there's a lot of info that I had to get through. And depending on kind of what we're doing in the future, I think you'll see some more in-depth one-on-one type setups from our field sales team and our sales guys out there to go into more detail. And then based on what we need to do, we may do some more of these that are in-depth in the software or the web UI to kind of deep dive on it. So hopefully everything was covered. If there's any questions, I've got my email address there, and feel free to reach out to me going forward, and reach out to your sales or your field sales engineer for any questions that you have. And always hit the support.com if needed, and reach out if you need to. Thank you, everybody. Have a good night.